Welcome to the Q&A session 17 from the chapter of properties of matter. The topic is the equilibrium state of a floating board. So based on this topic, I have selected one question for this session, and with the help of this session, we will be able to understand that what will be the equilibrium state of a floating board, and or we can say that in what condition a floating board will be in a state of equilibrium. So here the question is, a boat is floating on a lake which has a length of 3 meters and the width of 2 meters. The boat sinks by 1 centimeter when a man gets on it. So the mass of the man is. So here we have been given 4 options, and we have to find the correct option. So here the boat will be in a state of equilibrium when it has sunk by 1 centimeter when a man gets on it, only when the downward force is equal to the upward force. Now here the downward force will be due to the weight of the man. The downward force will be due to the weight of the man who has boarded this boat, and the upward force will be the buoyant force. The upward force will be the buoyant force. So when this weight of the man is equal to the buoyant force which is acting in the upward direction, and this weight of the man is acting in the downward direction. So when the weight of the man is equal to the buoyant force, so in that case the boat will be in a state of equilibrium. So here we have to find the weight of the man and we have to find the buoyant force. So now the buoyant force, say this is FB, this is equal to the density of the liquid, and here since the boat is floating on a lake, so the density of the water will be taken into consideration. The density of water into the volume of the boat which is inside the water multiplied by the acceleration due to gravity. So from here the buoyant force FB will be equal to, the density of the water is equal to 1000 kg per cubic meter. Now here we have to find the value of the volume of the boat which is inside the water multiplied by the acceleration due to gravity. So the volume of the boat which is inside the water will be equal to the length of the boat multiplied by the width of the boat multiplied by the depth of the boat. Now here the depth is 1 centimeter. So this is equal to 1 by 100. So this is equal to 0.06 cubic meter. So the buoyant force will be equal to 1000 into the volume of the boat which is inside the water, which is equal to 0.06 into G. And for the boat to be in a state of equilibrium, the weight should be equal to the weight of the man who has boarded this boat should be equal to the buoyant force. So the weight of the man, let us say the mass of the man is equal to m. So this will be equal to m into g. This is the weight of the man, and this should be equal to 1000 into 0.06. So this is equal to 1000 into 6 by 100 into g. So from here g and g will get cancelled out. So the mass of the man will be equal to 60 kg. So the correct option here is B, that is 60 kg. So here the most important thing which needs to be remembered is that in the state of equilibrium, the downward force should be equal to the this upward force, and in this question the downward force is equal to the weight of the man and the upward force is equal to the buoyant force. So thank you very much for joining this session. In the next session again, I will be coming up with a different type of a question which can be from the topic of Archimedes principle, buoyant force, or the laws of flotation. So till then, have a nice day. Bye.